Let's talk about designing flatback power supplies with multiple outputs. Let's have a look at the existing solutions for multi-output flatback. Over here, I've got a circuit diagram built on InnoSwitch, which is another power integrations product for flatback. So this is the primary side of the circuit. This is the secondary side of the circuit. On the primary side, we've got this primary side of the transformer, the switch of the primary side. The switch is being integrated in the switcher. It can be a power GaN switch or a MOSFET. So on the secondary side over here, I've got synchronous rectifier for better efficiency. And feedback is being sensed over here, sent to the switcher to regulate the output over there. The output, let's say, is 12 volt. I've also got this really interesting technology here called FluxLink. It's an isolation barrier crossing technology, unique PI technology that allows you to not having to use any optocouplers anymore. So that's the circuit diagram for single output flatback. Traditionally, when we talk about multi-output flatback, we're normally referring to one of the two solutions. So the first one is multi-winding flatback. I've got 12 volt here already. What if I need another 5 volt? I simply just need to add another winding on the secondary side of the transformer. Really easy. Don't forget about your switch here, very important. You can use a diode. I'm using SR because it's better for efficiency. Your dot, 5 volt. That's it. As simple as that. If you want more outputs, you just add more windings. This solution is really, really easy to implement. However, there's a really big limitation here. So normally with this arrangement, feedback is only being sensed primarily from one of the output. And over here is my 12 volt. That's my main output. That output can be very well regulated. However, the regulation on the rest of the circuit, not so much, not very good. And you don't want that. Say for this 5 volt, the regulation can be as bad or even worse than 10%. So what if you do want accurate regulation on multiple outputs? So if you do want accurate regulation on multiple outputs, you want to go for flatback plus DC-DC. So I've got 12 volt here. If I want my 5 volt to be accurately regulated, I just add a DC-DC, say a buck circuit over here. That's my 5 volt. So by doing so, the regulation on both outputs is going to be very good. However, the introduction of this DC-DC circuit will compromise your efficiency in the system because you no longer just have a single stage of power conversion. Now you've got two. Say the flatback efficiency is, for example, 90%. And then my DC-DC buck converter efficiency is, say, 92%. So if I'm looking at a design where I need, for example, 5 volt, 2.5 amps, 12 volt, a 0.5 amps. If I want that, then my system efficiency becomes 85% immediately. And you see that's a 5% difference because of using the DC-DC converter over here. And also adding the DC-DC converter here means that you might have to enlarge your PCB size, add the cost, add more component count in the system, and you don't want any of that. So is that it? The answer is absolutely no, because now we've got InnoMux-2. So InnoMux-2 is a single stage power conversion. You don't need DC-DC anymore. That means I'm taking that out, no longer need that. Of course, that 85% gone as well. All I have is just a single stage flatback, 90% efficiency. I have an InnoSwitch based circuit over here. I have one output, 12 volt. So how do I turn that into InnoMux-2? If I want the 5 volt, I just need to add a switch over here. Over here. There you go, 5 volt. Add some capacitors on the output. So this switch, we call it the steering FET or a selection FET. What it does is that it steers power to the output that's requesting for it. Really important thing about InnoMux-2 is that you want to be able to sense the output independently from each other and control them independently. That's why we need two feedbacks over here. Feedback 1, feedback 2. Not weighted feedback, two completely individual feedback. I also need to control the on-off of the selection FET to achieve the power steering. So that's it. That's the circuit of InnoMux-2. Let me show you how InnoMux-2 delivers excellent regulation on all of the outputs. Here's an example. If my 12-volt drops below a reference point, then the secondary side controller knows it. It's going to send a request for pulse to the primary side through FluxLink. When the primary side knows it, it's going to turn on the switch, let the energy build up, and then turn it off. On the secondary side, I turn on the SR. And then as long as I keep the selection FET off, the energy has nowhere else to go but to go to 12 volt. So 12 volt gets charged. Similarly, if 5 volt drops below a reference point, the secondary side controller also sends a request for pulse to the primary side. So primary does the same thing, turn on the primary switch, let the energy build up, turn it off. And on the secondary side here, I need to turn on my SR again. And then I need to also turn on the selection FET so that the energy only gets discharged to 5 volt because it has a lower potential. So this is exactly how InnoMux-2 works and why it can deliver excellent regulation onto the outputs independently from each other. Let's look at some test results. I have a 5 volt, 12 volt design over here. The test condition covers across load and line. Line is from 90 to 265 VAC, and load is from absolutely no load to 100% full load on both of the outputs, so 5 volt and 12 volt. With all of these changes, the regulation on both outputs is still better than 1%. And this is because we regulate the outputs independently from each other. To learn more about InnoMux-2, visit power.com.